All right, today we're going to be talking about the binomial theorem in Pascal's triangle. If you remember your warm-up question, or not your warm-up, your bonus question from Friday's quiz, kind of looks like this warm-up question where you have some like a binomial that is raised to a power that's not what you're used to. You're used to seeing maybe a 2, maybe a 3, but a 5, probably not. This is going to take a lot of work. You can do it. And that's what the warm-up is today, is for people to attempt this question. When you attempt this question, this really means x plus 3 times x plus 3 times x plus 3 times x plus 3 times x plus 3. When you multiply all of that out, you should get x to the 5th plus 15x to the 4th plus 90x cubed plus 270x squared plus 405x plus 243 if you take the time to multiply that out. And that was kind of a pain in the butt. So what we're going to do today is going to help you do these problems without having to, do all of that work. Okay? Kind of a shortcut, if you will. So this guy, Pascal, came up with Blaise Pascal. He came up with this triangle, and he's just a French mathematician. Old dude came up with this triangle to help us figure out binomials and kind of a shortcut to multiplying. This is his triangle, and you're going to get used to this triangle. You're going to memorize this triangle. It's going to be your best friend. Okay, so what I have for the notes today is, so basically you're filling this in. At the top you have 1, and then we have 1 and 1. So the pattern here is the outside is always going to be 1. On the outside here, it's always going to be 1. Okay, and so how we get this middle number here, we add the 2 numbers above it. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. You have 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. 1 plus 6 is 7. 6 plus 15 is 21. And then 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. It just goes on and on. That pattern continues. Okay, so what are some things you may notice? Well, some of the patterns you might notice, these are all 1s. These diagonals on the outside are all 1s. This row right here, these are your counting numbers. Okay, these are triangular numbers. That means they make a triangle. So that makes a triangle. 1, 2, 3. That makes a triangle. 1, 2, 3, 4, 5, 6. That makes a triangle. Okay. And then you have tetrahedral numbers, which can be represented as a pyramid. And that's the 4th diagonal here, 1, 4, 10, 20, 35. Just a lot of patterns. If you had the time to study this, there are a lot of patterns you can pick out of his triangle. All right. So another pattern, odds and evens. If you color the odd and even numbers, you end up with a pattern. Same as the Sierpinski triangle. And that is just made up of little triangles. And it just keeps going and going. All right, so how do we use this to help us in Algebra 2? Okay, so it's very simple. I know it looks complicated, but It's really not that bad. Okay, let's take a look at the horizontal sums. That adds to 1, that adds to 2, that adds to 4, that adds to 8, that adds to 16. So yet another pattern. As you move this way, as you add them, they are powers of 2. You're doubling each time. Okay, so each line is also the powers or exponents of 11. So 11 to the 0 power is 1. 11 to the 1 power is 11. 11 squared is 121. 11 cubed is 1,331. Powers of 11, okay? They are also symmetrical. The triangle is symmetrical, if you notice that when you're filling in your patterns, okay? So how this is going to help us, this is going to help us use binomial expansion, because whenever you have binomials and you have this exponent, you are technically expanding this. Okay, so let's apply these and see what we can come up with. All right, so here, and whenever you're doing your own problems, this is how I want you to set it up. So let's look at this example. We have our original binomial. I think this was your warm-up.
To each reception. I'm reading things to each reception.
Okay, we have x plus 3 to the 5th power. So we have two terms. Let's go here. Right? Here and here. And then, so how you're going to use your triangle, whatever power it's raised to. This is raised to, oh my goodness, so this is raised to the 5th power. So you're going to look at that 5th row in your triangle. So if we look at row 5, so if you look at row 5, that's here. 1, 5, 10, 10, 5, 1. Those numbers are going to go here. 1, 5, 10, 10, 5, 1, and then you have x here. X, 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 and then we have plus 3. So we're going to use 3, 3, 3, 3, 3, and 3. Okay, so how we fill in, you need to fill in the exponents, okay? So I'm going to start with 5 and work my way down. 5, 4, 3, 2, 1, 0, same thing. 5, 4, 3, 2, 1, 0, and then this part you are just multiplying it out. So 1 times x to the 5th times 3 to the 0 power, that's going to be 1 times x to the 5th. Anything to the 0 power is just 1. So that equals x to the 5th power. 5 times x to the 4th times 3 to the 1st power, that's 5 times x to the 4th times 3. 5 times 3 is 15, so that's 15x to the 4th. Okay, 10 times x cubed times 3 squared. 3 squared is just 9. And this was x cubed and 10. So 10 times 9 is 90. So that is 90 x cubed. So we have 10 times x squared times 27. And that gives you 270. X squared, 5 times x to the 1 power is just x. Times 3 to the 4th power, that is 81. 5 times 81 times x is 405x. Then we have 1 times 1, 1, and then x to the 0 power is just 1. 3 to the 5th power is just 243, so this is just 243. And how this works is this is what you would write out in standard form. This would be your answer, okay? And that's all the time I have left for today. Your homework is to do these 4 questions, and you're going to submit that, okay? When you're setting up your problems, you set them up just like we have here.